All right, welcome back, everyone. Today we're gonna finish up the deployment demo, and then we're gonna go into auth and images. We had a little bit of a mistake in the schedule. So last class will actually be this Wednesday, and we'll talk about that a bit later. But for now, let's just finish the demo real quick. Okay, so what we did last time was let me draw it up. Okay. Okay. So last time we had the local here, app.py, db.py. We have a Docker file, and we have a Docker compose. And what we did was we used a Docker file to build an image into like something that looks like this. We pushed it to Docker Hub, which stores a lot of images, right? And then we had our server, we set it up already. This is our like our Google Cloud GCP server set up. We have our VPC network. And inside of these, we have different subnets, like different regions, right? So this is like subnet 1 or like US East. And inside this, we have a virtual machine in which we pulled the image we have here into that virtual machine, and we unboxed it and we ran it as a container. So it has like a container here. And the way we run this, so this was full, and we run it here. We run this using the Docker Compose YAML file. And actually that we did this locally, not yet in the server. So today we're gonna do that in the server. So over here, this is our Google Cloud. We have our VM instances. We have this VM instance right here. So let's SSH into that VM instance by just clicking this button. So this is us getting access. It's like connecting my laptop to the terminal inside that VM here. Large this. Right. So here let's see if there's anything. There's nothing. When I do list ls, you can see there's nothing in the server. The server is completely empty right now. And what we have to do now is we have to install Docker. We have to install Docker Compose, and then we have to do the rest of the steps, which is to pull and run. So let's do that. Let's see yeah, I will have to use this. Over here. Right. So last time we left off over, where was it? After making the VM. Right here. Okay, so let's just follow this. We don't want to set up Docker Hub. We'll set up Docker Hub in step 7. Step 5 for now, we'll be building our Docker image locally and pushing to Docker Hub. So that'll be this step, building and pushing to Docker Hub. So we actually just run this command here. So Docker build, and the platform, we set it to Linux. And because we're using Ubuntu, we have to use a specific platform. And then we can tag it with whatever we want here. So let me copy this and let's try and build our Docker image. So if I go to the terminal, let's first see what images we have. We have a lot of images here. So let's build it using this. So Docker build platform Linux AMD 64. We're going to tag it with my account, which is JD2262 / demo 5. And then let's name it V1. Actually, there are a lot here. So let's name it V4, actually. V4, like that. All right. That's this part building. Does anyone have any questions up to this point? Does anyone need like a refresher on the whole like pipeline we use? Good. All right. Building. Okay, while it's building, let's actually install our Docker and Docker Compose on our server. So after this command, the next thing I'm going to do is I'm going to run Docker push so I can push a Docker Hub, which is that step going up. But then what we're going to do next is we're going to install Docker and Docker Compose. So all you have to do is just like click these links that I put here. And in this link, you can see we can just download Docker using these commands. So you just copy these. So first, just update sudo apt update, and then you go down here and just copy all of them basically. E. What happened? This is weird. But I am. Not root. This. Oh, using the wrong count. What is this problem? Okay, that worked. Not sure what the issue was just now, but it works. Okay. Yep. And we keep going. We install this, right? And then this, update again. Okay. Yeah, and once I do this, you can see Docker is installed. And if you just keep going, install this. Yes. Okay. We can check that it's running after this. All right. So to check that it's running, we just run this command. You can see it's running. You can control C to stop. Yep. Yeah, there you go. So this part is done. So now we have Docker, and now we just need Docker Compose. So you can see the second guide here. You can just follow this one. Yep, and you just start copying the commands again. 1, 2, 3. And you can see we have the Docker Compose installed already. The version is 1.29.2. And yeah, that's it. So we've done step 7. Let's actually go back to step 5 and see whether or not we've finished building. So here, yeah, you can see the build is done. If I do Docker images to check whatever images I have, you can see demo 5 v4 is here 4 minutes ago. And now I just have to push. So I can run the command like here. So I can run Docker push to the specific repository. Let me change this. So that will be JD2262 slash demo 5. And then the tag is just v4. And then I think that's it, right? Yeah. And this will push to Docker Hub, which is this step. And then the last step is for us to pull and run the container. So right now in our server, that's ls, there's nothing here. We need to add a Docker Compose file because remember we use this Docker Compose file to run the containers. And we have this in local right now, but we don't have it in the server. So we actually have to copy this over. So we have to copy this into here. We have to copy, like just manually copy it. Um, because it's not included inside the image. This is just separate. We'll just copy it. So to do that, should go here. You can use Vim, you can use Nano, but all of these are all just basically text editors in the terminal. So let's just use Vim in this case. I can do Vim docker dash compose YAML. So right now there's nothing in my server. When I run this Vim and a file name, it will create this new file, and it will. Oh, it doesn't have Vim. We have Nano. Don't. This is bad. I will use this command. So let me install Vim first. Okay. Why is this not today? Okay, nothing. Okay, let's install Vim first. Yep. And now I should be able to do Vim docker compose.yaml. Yeah, there you go. So you can see it opened like this text editor, and I can type stuff and I can add stuff here. What I'm going to do is I'm just going to copy the Docker Compose file we have. All right, so this we managed to push. But over here we have our Docker Compose. It looks like this. I'm going to change this to just v4. And let's take this, copy it, and then just paste it here. And then there are a couple of things in Vim. So you can't actually just like I don't you can delete, but this is a special text editor, and there are a couple like keys you can press. So if you go here, I've listed a couple keys you can use. So pressing I will allow you to enter like insertion mode, which we were already in. So in here you can see it's insert down there. That means we're in insertion mode where we can edit the file. And you can press escape to exit the insertion mode. And then to like save the file and quit, you can do colon WQ. That's how you save a file in Vim. So let me press escape, and then I'll do colon WQ. And you can see I wrote it down there. I press enter, and I list again. You can see we have a new file called Docker Compose. And to print a new file, I can just use cat Docker Compose. That will print the file. And you can see we have the text file like basically there. We just made a new file using Vim. Yeah. So now we built it, we pushed it, we set up our server with Docker Compose and Docker and Docker Compose. We have our Docker Compose file. All we have to do now is run it using Docker Compose. So I mean pull first and then run. So we want to run Docker pull. What is the command? I think it's just the same repository like this. I think. Yeah, it is. Let me use sudo like that. So now I'm in the server and I'm pulling from Docker Hub. Um, yeah, skip that movement. Okay. So I can run the same commands as we usually do. So I can do Docker images. Oh, sudo Docker images because I need permission. So sudo Docker images, I can see I have this new image, which is exactly the same as how you can see the Docker images in my local. So like locally right here, Docker images, you can see all my images. Same thing. Over here, I can run sudo Docker images. Sudo is just a command to use the root user, so I have access. And you can see I have this image. Now we can run it using sudo docker compose up, and I can use the dash D tag to show that we're running it detached, but let's do without first. Uh, I, I think this is just disconnecting for some reason. This is so weird. Okay. So sudo docker images, and then now we can run it using sudo docker compose up like that. And we don't have an environment variable file apparently. So this was what we added last time. This is what Lauren added last time. We added an environment variable like feature where you have a .env file like this, and then you can put your name and an ID, stuff like that. So let's just copy this over. I'm gonna copy this, and then we're gonna use vim again. So vim.env, a new file. I paste it in. I can exit and I can save the file using wq. That if I ls, you can see. Okay, if I ls, you can't see an env file because any file with dot blah 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 with an extension is usually hidden. You can see it using this other tag. So you can see all the hidden files. You can see all of these are actually hidden. But now we have the .env right there. And I can print it out just using cat like this. You can see that this is our environment variables. And hopefully if I run docker compose up right now, it should work. Ah, there you go. So you can see it's running, it's created all the tables and it's running on this address locally. But what we can do now is we can go to our VM instance here. You can see it has an external IP address here, like that. And if we click this, ooh, this should be slash what? There is there is a base route. It does not work. Okay, let me control C and stop it first. I will have to debug this. Okay. So let's sudo compose up with the dash D so it's in detached mode. Okay. So sudo docker ps to see what is running. This is running on the ports 5000 to 5000. Sudo docker logs, and let's copy this. Yeah, it's running okay. And now let's try this again. Slash task. Let's try that. Why is it not running? MO5 v4. It's running. Why does this not work? I need to go into. Might be the port. Yeah, I think it's the port. I use port 5000, 5000. I think it doesn't work for some reason. I remember having this error a long time ago. Okay, so to change the port, we have to go back to app.py. Um, ED50. Change this to 80. And then we have to update our Docker compose later on. Will this work? Where's my notes? Yeah. Let's make sure it's 8050. So we go back to our server. Let's vim our Docker Compose again. Let's change. Okay, we press I to insert, and then let's change this to 80. All right, escape WQ. Okay, so let's cat it just to make sure we changed it. Okay, we have 80 here. And now let me compose down first. So I stop the container. Um, okay. So now we compose up again. HD. Check if it's running. Sudo docker logs that. It is running, and let's try this. There we go. That was the issue was the port. So yeah, as you can see now, if I use the external IP and I do like /task or slash like a base route like this, you can see that our server is up and running. And if any of you guys try that link right now, you should have access to the backend. So if you just copy this like on my phone or anything, right now there's no HTTPS, but HTTP 3421.10.96, you'll have access to our backend, and our backend's live. So yeah, thank God that worked. I believe we changed the port to 5000 because we were trying to test that last time. But yeah, just use port 85,000. As a reminder, the port 85,000, like here, 80 was the container's port, and 5000 is our where our app is running inside the container. So yeah, any question up to this point? Our app is finally live, and yeah, it's up on a server, and that link, this link, this is what you guys will give to your front end developers when they want to connect to your backend. You just give them this link, and they can do /task/users, whatever, to access your backend. Yeah. Any questions? Hope it wasn't too messy. But that's just a glimpse of how you would debug. Yeah.
So when you have to like say you want to add like a new route, right?
Yeah.
So then you like remake your Docker file. How would you like update that inside here?
Good question. So if you update your app.py, like one of these files, this, or this, then you have to build again, you have to push again, and you have to pull again, and then run again. So you have to complete the entire pipeline again. You don't have to like, if you change Docker Compose, that's why this time I was changing Docker Compose, just changing 5000 to 80. I changed it only in the, I could change it locally, but I was changing it mainly in the Docker Compose in the server, because that's what you use to run. That's not actually included inside the app. It's just a file you use to run. If you want to change anything in the app, then you have to rebuild, repush, repull, and then rerun. Does it make sense?
Yeah.
I think when I was learning this, I wasn't clear when I had to rebuild. So even when I was changing this, I actually like rebuilt the image and did the entire thing again, although I didn't have to. But yeah, just take note, this is separate. This is what you use to run the container. And then if you change anything of this, then you have to like rebuild and do the whole thing. If you're changing environment variables, then you don't have to, because environment variables, remember, we also copied over .env. This was also copied over. So yeah, you had a question?
Was there a reason that we have like Docker and the TCP server separately if we're just gonna send the image to the server eventually?
So we installed Docker and Docker Hub here. Is that your question? Why we did that?
I'm just like curious in general why we have to have like Docker Hub like kind of like as a middleman to take the images and send it to the server.
But if we don't use that, how do you think we would get the images from local to server? Like we had to copy them over? Is that your idea maybe? Or
yeah, I was just wondering why the server just doesn't like take both or take the images directly
from the local?
Yeah.
So you mean like just copy like these, right? Like maybe just copy the image over to the server?
Yeah.
That is a good idea. First of all, they're kind of big. It's really not really that like private. Like it's not really secure when you want to upload images directly. I don't actually don't know how to upload images directly, but you're right that Docker Hub and Docker. The reason why we have Docker Hub is just as a middleman to transfer the image.
Okay.
But yeah, I'm actually not sure why we don't just upload directly. But yeah. Any other questions?
So does this mean you have to report our backend to the server before the front ends can connect to the backend?
Good question. So if the front end people want to access it online with the internet, like using Wi-Fi, then yes, you have to do all this process and then they can access through that 34, 21, 10, 96. But if they want to test beforehand, like you're having trouble with deployment or something, right? What you can do is you can run it on your laptop and then give them the local network IP address. Like remember how last time you can use that link and then they can test it. But they have to be close to you, obviously, right? Or alternative number three is you can send them over your code and you can ask them to run it on their laptop. So they can do it like in their dorm and if you're far away. That could also work.
What we have now is like, we have a GitHub repository, so everyone has a version of the backend. So can they possibly do or test it on their computer?
Yeah.
From the repository?
Yeah, absolutely. So what they'll have to do, they have to clone the repository, as in like copy over the files to your local computer, and then they can just open it up, install the virtual environment using Python, pip install, blah, 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 and then run it locally. And then when they're connecting from their front end app, like iOS or Android, they just use the like 127.000.001, something like that. Yeah, they can do that. And then only for the hackathon, you don't necessarily need to have it deployed. It's good practice if you want to try and deploy it, but some people, they just have it locally, and then when they demo the app in the video, they just show it running locally, but it looks like it's live. That's fine too. Because yeah, deployment is a heavy step. There are a lot of little details. Like just now, I ran into one issue, but yeah, if you guys need any help, I'm happy to help debug any of this. So yeah. All right, let's get to the next portion. We're going into auth and sorry. And this is your name. We're going into auth and images. You're doing auth? But cool.
Okay. A few announcements. This is the last week of class, unfortunately. Also, your midpoint submission is due tonight, so make sure to get that in. It's a really quick form, so it shouldn't take that long. And also, your hack challenge submission is due this Friday, and then we'll have midnight office hours on Thursday from 8 to 12 if you need any help with your project. That'll probably be somewhere, I think Phillips Hall. And then our last class, we aren't sure what to do. Last semester we did a panel with alumni from AppDev, specifically backend members. So if you're interested in that, we can have that panel. But it's also up to you if you guys have any suggestions or.
So we want to open this up to the floor. Like last time, what I added was this panel, like supposed to be like a career panel if you guys need advice on like internships and stuff like that. But I feel like that was only useful for like 5 or 10 minutes. So my suggestion is we can talk about extra topics in backend. So if like last time already you asked about like NoSQL and what that is, we can talk about topics like NoSQL versus SQL, talk about topics like MVC, model view controller. We can talk about more advanced backend topics at a surface level, not too detailed, just to give you guys a taste of what else is there to learn after this. And I mean we could have that as well with the panel. But I just wanna, does anyone have any ideas? Like what do you guys want to like get out from the last class, or what do you guys want to leave here with?
Or we can do a poll, like an ed poll.
We can do, yeah, we can have a discussion as well, but ideally by like tomorrow we have something sorted out. Wait, okay, just show of hands. Who wants to have like the panel with a bunch of like AppDev backend members? Yeah, okay. So maybe we'll have that like in the last 5 or 10 minutes. And then maybe after you guys can chat as well. But who would find the extra topics more useful or helpful? Anyone? Yeah. Okay, so we'll do like a 50-50 then maybe. And then maybe we'll thread in Ed to see like what topics you guys want to learn about. But yeah.
Okay. So we're gonna go into authentication.
Oh, you want to jump?
So why do we want authentication? Obviously, security, verifying someone's identity, and just avoid people getting sensitive information. And the basic HTTP authentication flow is not that secure, and we'll show why. Basically, you're storing encrypted credentials in the database, and the browser saves these credentials temporarily. So you send the credentials with every request, and anyone can intercept the request and receive those credentials, and then like use your credentials to get more information from the database. So, for example, if you're logging in or if you're creating account on Instagram, you would store your email, full name, username, and password in the database. And then when you log in, you use your username and password, and then this um is stored, or this logs you in into, like, you hash the password that you enter, and then you compare it with the hash password in the database, and if it's the same, then that logs you in. However, when you send a request, like a GET request, you send like these credentials basically that store your username and password. So this is like a base 64 encoding. And if you go on Google and you copy this, like this string, and decode it, you can basically see what the username and password is. So I like if anyone wants to do that right now and tell me like what it decodes to, um, yeah, it should be like it should take literally like 5 seconds to copy that, and then you can see it turns into foo:/bar, but this is like very insecure because, or not very secure because anyone can intercept this request and decode it easily. So yeah, the credentials are exposed in every request. There's no easy way to log out. And the credentials are stored in the browser until you clear like the cache or the browser is closed. So to solve this problem, we have session tokens. So this is HTTP session authentication. And this uses session tokens, or yeah, it uses sessions, which is a time period for when a client and a server can freely communicate. And you do this through a session token, which is created on login. And it's stored as a separate table in the database and is unique to each user. So what I can use like an analogy. Let's say if you wanna go to an amusement park, right? So use your ID, use your credit card to buy the ticket. So the ID, the credit card, that's sensitive information. That like acts as your username and password. So you use that initially to buy the ticket or to buy like a wristband for like the amusement park. And then when you're in the amusement park and you want to go through different rides, like let's say like the rides are different endpoints that you're trying to hit, you basically use the wristband to prove that you're like you already paid and that you're like already logged in basically, right? To get onto the ride. So that wristband, that's your session token. So it's not actually like holding any sensitive information. It's not like holding any like credentials. You only use the credentials once basically, if that makes sense. Um, yeah, and the session always like expires after a certain time. So like when the amusement park that closes, for example, that could be like when the wristband expires. So that's like kind of an analogy that I like to use. Um, so how does this work? Basically, when the client signs in with the credentials, the server will validate these credentials and then create a session token. And then once it creates a session token, it basically gives this to the client. And then if the client wants to make a new request, make a GET request, POST request, it will include the token with the request. And then the server will get this request with the token and then like do whatever it needs to do and then give back the information. So I can like, let me draw um, this. Um, okay. Let me just Okay, let me explain the two different types of tokens you can have. So the first token is the access token, which I was talking about earlier. So this only lasts a few minutes to a few hours. So usually it's like 15 minutes. And then we also have refresh tokens, which are a lot longer. So this could be like a week, 2 weeks. So when you make requests, you're using the access token to make that request. But then once that token expires, it only lasts for 15 minutes. So you don't want to keep logging in every 15 minutes. That's too much. So when the token expires, you want to renew that token. So how do you renew that token? You use the refresh token. So when the client logs into the server with like the username and password, the server basically verifies his username and password and then returns an access token plus the refresh token. And it will also like include this into this table. So if I'm user ID 1, it will do this, and then it'll create access token, create a refresh token, and then send the access token, refresh token back to the client. So whenever we want to make like a GET request, like get profile, you include the access token. So you give also the access token through the auth header. And then the server will look into the session table, look at the access token, see the user ID, and then like use the user ID to like get information and then send it back. Right? So what happens with the access token expires, then you have this another endpoint called refresh token. And then here you give the refresh token. And then it'll give back a new access token. And a new refresh token. So once the access token expires, it expires after 15 minutes, the client will call refresh token with that refresh token, and then it'll renew the access token and then like refresh it basically, and then give back that new access token and new refresh token to the client. And all the client needs to do is just like store this access token and refresh token on the browser, and then it just uses the access token every time. But the access token doesn't include any sensitive credential information or anything, so that's why we use tokens. Yeah, does anyone have any questions so far? This is like the wordy way to explain it. Yeah, so you log in with the credentials, you get the access and refresh token. Anytime you want to make an API request, you use the access token to validate. And then once a token expires, you have to refresh the access token. And then, so you send the refresh token to the server, and then it validates and returns a new access token. And then, yeah, there's also automatic refresh as well. Yeah, so this is an example of how the session table would be. So this is like kind of what I have here. You have the ID, access token or session token, same thing. Expires at, I forgot to add that, and then refresh token, and then the user ID as well. And then when you're querying it, you just get the user ID from the session token, and then with the user ID, you can do whatever you want with the database. Yeah. Yeah, and this is more an authentication. OAuth is just like, wait, let me see. It's like when you ever you see like login with Google, login with Apple, that's what OAuth is. And then, yeah, JWT token is also a token, but it includes like some information as a JSON object, and then you have multi-factor auth, and then these other auth types as well. Wait.
Yeah. So if this wasn't like, because this was really fast, if you want more explanation after class, I'll be happy to go through this like really quick one more time. But let's speed run images before we end this class. So images, how do you think we store images on backends? So imagine you have this backend, you have the names of fruits, you have the quantity, the price, etc. And you want to store them in a table, and you have like integer, text, integer. These are real numbers. But what if you want to store like images, right? How would you actually store the image? For example, like profile photos, Instagram posts. This also applies to like videos too. But just any kind of large content that doesn't fit into integer texts or other different data types, how would you store that, right? So there are three ways to store it. There are definitely more ways, but like this is just a short summary of three. So first, you can store images as blob. We'll talk about what a blob is. Number two, you can store the image as a local file path in the database. So in our table, like over here, we can store it as /users/Joshua/images/apple.png, for example, as a path. Or number three, we can store the image URL instead of file path. We store it as a URL in the database, and that's ultimately going to be the best method. But let's walk through all three of these. So let's go through the first one, which is a blob. What is a blob? So a blob is a binary large object, BLOB. It's a blob of data. It's just binary data in the form of like text, and you can store a lot of things with it: documents, images, and videos, audio, stuff like that. But it's just binary data. This is what blob looks like. It's just a bunch of characters, and they're really, really long. If I convert like an image, like a small image to blob, it can be like thousands of lines long. But it's just a way like to store, to display or store content as just binary. And that's how it looks like in text. And the benefits of this is it's easy to implement, and that's about it. It's not really the best method, but database storage is quite expensive, and they're designed for structured data like your profile, your users, stuff like that. And also storing blobs in them will just be really slow. So what this looks like is you would have a table sort of like this, like the ID name of the user, for example, and you want to have their profile image. One row would just be like one Josh, and here would just be like a bunch of like 1,000 lines of text that just stores my profile image. And imagine every time you want to query, you want to get my profile image to show it, for example, you're gonna get this row, for example, you're gonna get a huge amount of text back, and then you're gonna have to like display the text. So it's just slow. And what if you get like 10 users at a time? What if you're trying to like copy over data? It's just really, really slow. So you don't want to like use blobs, although it's really easy. For my hack challenge, I actually use blobs for images because they're really easy. All you have to do is convert an image to a blob, to base 64, which you can just do like PNG to base 64. Something like this. You can just pop your image there and it'll give you a base 64. But yeah, you just store images as text basically. That's number one. Number two, you can store as a local file in the database. So in our server, we can actually store our images in the server, and then we store the file path. So we have like different types of file paths, relative file path and absolute file path. I'll gloss over them really quick. Relative file path will be just the folder / your image. And absolute file path will be the entire, like your entire computer, all the way to the image, for example. That's the difference between the two. You can store either one of these. And yeah, servers are just computers and images are files. So you can store it as an image and then you can have this a path. And you can add a post route so you can access and like you can basically store images with just a path. And that's faster because instead of a blob, you have just /images / blah 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 .png, for example, instead of a blob, which is better. So it looks something like this. You can have your source folder, you can have images on the side. And a lot of front-end projects they actually do this. Have a sort of structure like this. But yeah, it will look like that. Yep. The benefits, it's faster, better than blobs. You don't need any special coding or pre-processing, and the backup is asynchronous. Like, yeah, I'll just skip over that. The drawbacks is storing large volumes of data inside your server is not ideal. You don't want to have your server, which like last time I showed you how expensive the server was when I was buying it from Google Cloud. It was like $14 a month. If I want to store images, I don't want to have like a server that's really big. It'll cost me like hundreds of dollars. And access to the files depend on the server. The server is down. That means you lose access to the images. So recall clustering here, and we can actually use another server attached to our backend. So that's where we use the URL. And how do you think we make an image into a URL, you might think? Well, we use cloud-based storage. So you can use something like AWS, like Amazon Web Services S3 buckets, and they will store the images for you in a specialized like server. They support really good stuff here, and they'll give you a URL back. And what we do here is we just change this instead of this, we have a URL. So this is another diagram of our whole stack. We have our client. You can send a request to our app, right? And our app, to get a profile image, for example, here, you would go to AWS and get an image URL back. And then we give that back to our, we store that in our database. And in our database, we have these now. We have this like /mybuckets /uploads, blah, 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 blah. And that's stored in another server, a specialized server for images. And this way, it's more reliable and scalable. Files are secure. If your backend's down, your images are safe. And you can access every file from any server, depending on who you allow to access the images. And we will not have a demo for this, but if anyone wants to see like a live instance of AWS, I have a project I can show you. But that's just after class. So let's go into the Kahoot and I will take any questions. Does anyone have any questions? Yeah.
So image URL storage, eventually we're like at the end of the day, we're still using some kind of cloud storage to store these images, right?
Yes.
So like what difference is that from the second option where you just store the images as a path?
There are a few. Let me stop. Actually, this might be good. Okay, number one, it's specialized service for images and large files. So compared to having your own server where you have to manage like what if your server gets full or what if you have to add another server, AWS will manage that for you. So you can always like you'll always have space basically. You don't have to worry about space, only about the cost of the space. Number two, you don't really want to clutter your database with images. It's not really the best practice because imagine like my laptop, if you just put like a million images on it, it'll get really big and it's heavy, right? You just don't want to have that. You want it to be separate, like a like a hard disk, for example. That's basically what it is. What else? It's accessible from different servers, and the accessibility is from a URL, not from a. I mean, it is a route, but like not from. You don't have to make a route yourself. Although you actually do. But yeah, does that kind of answer your question? Yeah. You can store it locally in the server, but once you scale it up, it's not the best practice. Anyone hasn't gotten in? Running a little bit late. Sorry, guys. Okay, let me start it. Anyone? Good? Okay.